Welcome to episode 2 of the tablet series. Today I would like to talk about how the tablet works and how I made it to work. I will also be talking about specific libraries such as matplotlib, numpy, and mysql. I would also recommend watching the first episode on my channel before watching this one to get a better understanding on what I'm talking about. So I'll be using the Raspberry Pi, the microcontroller and single board computer that we'll be using for this project. You can use other microcontrollers such as Arduino or the BeagleBone, but I will be using Python and Raspberry Pi for this project. Coming out of the Raspberry Pi are 3 different parts, or what I would like to say, nodes. These nodes are the database, OpenCV, and PiGame. Each of these nodes is responsible for one of the modules. Since PiGame is probably the easiest to explain, I'll start there. So what is PiGame and how does it work? Well, PiGame is the software we will be using to blit application code onto our screen. On this screen we can put anything we want, like buttons or random text. In addition, we can simulate mouse events by detecting clicks. So for example, let's say we click inside the button, we can actually detect if it's inside the button using mouse events. With that in mind, we can create a screen with all of our desired classes or features, like the time module, weather, and graph. Then to access these features, we can click on and simulate button presses with our fingers and query the mouse position. We can then decide if the mouse position is inside the button. With that over, let's go back to our 3 nodes that we established before: PiGame, the database, and OpenCV. Let's check out another one. So we'll check out the database. So how does the database work? There are 2 things that you can do in a database: querying and inserting. Inserting is when we insert our data into the database for later use. Later, when we access the database again, we can query the data that we put in before. We can do this with Python MySQL, a binding of the original MySQL language for Python. With MySQL, we can create tables and databases to put our data into. In addition, we can also access our database wirelessly through an IP with a user system. We can also give permissions to certain users so that no one that we don't want to has access to our database. As you can see right here, this is a table that we are building up. Inside a database consists of tables that we can store specific sets of values into. This means that we can have multiple tables for different things inside our database. This example has 3 categories: an ID or primary key, a city, and a zip code. We can then place different values into the table and then retrieve them later with a query. We can use this feature in our calendar module. For example, let's create a table inside our database with categories A, B, and C. We can later replace them with description, time, and date. Now we can store whatever our user gives us into our database. Then we can retrieve it later from our previously mentioned query. To further utilize MySQL to its fullest, we can use the famous requests library. This library is incredibly useful. It lets us scrape data from the internet from websites that we choose. We can also request data from an HTTP server. We use this for our weather module. When we give the screen our zip code, we request data from a weather API that I've installed with that zip code. This returns back all of our useful data like temperature high and temperature low that we can plant inside our database. Before I talk about the graph, I would like to discuss how the 2 Raspberry Pis communicate. The first step to communication is to have both of them connected to Wi-Fi. When we start off, we only have one Raspberry Pi connected to the internet. We can connect to internet with NMCLI, or short for Network Manager Client. Using this, we can easily connect to Wi-Fi from the command line. Then if the password is right, we can use a Bluetooth server client system to send our SSID and password to the other Raspberry Pi. Now both Raspberry Pis can have internet access. With both Raspberry Pis now connected to the internet, we can now effectively send data from one Pi to another with a database. This allows us to send useful information such as graph information or other data we want. We can use this feature in our graph module. The two libraries that we primarily use for this is matplotlib and numpy. Matplotlib is a visualization library for Python which allows us to envision our data. NumPy is a math library for the uses of matrices and arrays. NumPy gives all sorts of features that we can use to create curves for our graph. With this, we can also combine PiGame and matplotlib together. This means that we can split our screens that we make into a live interactive user interface. Then we can use that data to show what's coming out of the sensor. We can do this with functions such as pygame.surfaceArray or screen.split. For example, we could show simple parabolas to show our data. In addition, we can show cubic functions, but we can also show trig functions to spline our data so it looks more natural and realistic. We can also use linear functions and many others. We can also use matplotlib to show 3D objects such as this Raspberry Pi that I made. We can use this to fritz our cables later. Here's another example I made. This one was made using the QLone app, but we can visualize it with matplotlib. We use this to construct our 3D model before actually building it. Let's look back at our nodes before. Let's check out the last node that we didn't talk about yet, OpenCV. OpenCV is a library that we use for the photos and camera modules. It reads and shows images to us. Let's first check out its use on the camera module. So this is a simple camera that I've connected to the Raspberry Pi. It is a simple USB webcam that can project 720p images. Adding on to this, we can set up an HTTP server that can display our live camera view. We do this with two libraries, Motion and Flask. The Motion library reads the camera that we have already set up. Flask takes the images of the camera using Motion and puts them onto our own website that we can create, essentially an HTTP server. The server works by processing thousands of images coming from the camera and streaming it onto a website. Then the server converts these images onto an MOV file that we can extract to put onto our screen. We use OpenCV in a slightly different way for our photo module. But first, I would like to explain the color types for photos. The two we are using are RGB and gray. However, OpenCV's default is BGR. BGR is the exact opposite of the RGB system that we want. However, we don't want BGR systems, we want RGB. So we can easily figure out how to convert these values with some math. To get our BGR to RGB, we can just flip the array on itself. This will completely reverse the array, allowing RGB to return. We can do a similar thing with BGR to gray. All we have to do is use a function in NumPy called grayscale. All we can do now is just grayscale the image, and we will get our gray. We have now talked about all the nodes now. But the time module is the only one that I haven't explained yet. The time module is easily the simplest out of all the features on the screen. As you can see, we can move our mouse around the screen, and clicking on it will lead us to this type of screen. Using the standard datetime and time modules, this simple screen shows the live time as well as the date. In addition, it can also say good afternoon or good night based on what time it is.